Good morning, everyone. I'm Dave Cleland from MBSI Wave in Medicine Hat, Alberta. And this is a continuation of my Tech Talk series. We're going to kind of take a different turn. In the past, we've been talking about the new technologies that have come along. We've talked about some basic RF parameters, all sorts of things that we've talked about. And I've had some requests to talk about the physical layer and layer 2 of the OSI model. We're going to get into that in a minute here to see what it's all about. The networking that goes along with broadband radio is quite simple from a standpoint of networking, and yet it has some very complex characteristics that we have to take into account when we're building a network, when we're designing the network, and we have to know about them when we're fixing the network. So we're going to take a little delve here into the OSI model just a bit, and we're going to talk about layer 1 for the next 2 or 3 sessions. All right. So the OSI model, what does it do? We're going to focus on layer 1. What does the PHY do? What does the PHY not do? And what are examples of PHY in the broadband world? The OSI model is made up of 7 layers. This is a description of how one human being communicates with another human being through a machine that we call today a computer. The layers of the OSI model describe what happens to that communication. If I start to say hello to you, that's at the application layer. My presentation layer is then you looking at me and hearing me. The session layer is the conversation that we have, the fact that you recognize me and you give me permission to speak and I give you permission to speak back. The transport layer is the medium that I address you with. When I'm looking at you, the transport layer is that recognition layer where you look and you see what my facial expressions are, and you can tell what the mood that I'm in and how I'm speaking to you. In the networking layer, it's everyone in the room, everyone that can hear and can see what's going on here. This would be the type of the networking layer. The data link layer is the actual voice communication as my vocal cords take and resonate and vibrate and move the air that's coming out of my chest. That would be the same action as the data link layer. So it's kind of the culmination of all of the rest of the processes, from what I've thought through how I've taken and addressed you and gone on. Finally, we have the physical layer. That's the air that's between, say, my mouth now and this microphone at this moment. So as my vocal cords in the data link layer have taken and modulated the air is the actual physical layer that connects my voice to, in this case, the microphone that I'm wearing here, the lapel microphone I'm wearing. And then ultimately, if you and I were standing face to face and we were talking to each other, your ears hear what my voice modulates because of the fact that the air is affecting your eardrums. So we have this communication system. Then when you answer back, if I've asked a question, you answer back, exactly the same thing happens, but in the reverse order. So we're gonna relate this a little bit to how machines talk to each other, which is what we're primarily talking about here. In this case, broadband machines that we're dealing with in our world here. So here's a case of what the application what the OSI stack, if I want to call it that, looks like as we communicate from the left-hand side to the right-hand side. Ultimately, application speaks down through the stack until it gets to the physical layer. The physical layer is connected to some other device physical layer, and then the message is received and passed back up through the OSI model, back up to the application layer. So we have this handshake going on all the time. Why is this important? Well, this is important because of the fact that we have to describe the communication that we're creating in between two machines. We have to take and ultimately understand what's going on in between the two. If I have a problem in this system, I got to know where the problem is. I can't just start troubleshooting and shotgunning the problem. I have to know what's going on, where the system is breaking down, and what it's doing. So we're going to concentrate today on the physical link. The physical link's only job is to make a connection between two devices. The connection may be millimeters. In the case of chip-to-chip communications on a circuit board, or it could be as many as communication between different worlds. For example, if the Mars rover, for example, is, the scientists want the Mars rover to move forward, well, they send a command from the control center here on Earth. The control center is connected via radio link, ultimately. The physical layer is through space and up to Mars, and the rover will then take and decode the message and put itself into gear and move. And so that's the job of the physical layer. So what do our physical layers look like? Examples that we're familiar with. So we have unshielded twisted pair and shielded twisted pair cable that with a network interface of some sort. We use a jack and a plug system commonly known as RJ45. We crimp it onto the cable, plugs into the device. The devices are normally female connectors like we have here on these two routers that are in front of me here. And then the cable that's connected between them, of course, we'll take and make that connection. How do we know we have a connection? Well, I've plugged them in and I have some LEDs that are on that tell me that yes, there is a physical connection between these two devices. And fiber optics, world's a little bit different. We have one or two strands of glass that are connected into what's called a small form factor pluggable module, an SFP, and these modules interface with the switch or the router or the whatever the device is, the radio system that the module is installed in, and the communication, the physical layer, is then light that travels down these strands of fiber optics. You can see the strands there that are sticking out of this example cable that I've got there. And then finally, another PHY that we're ultimately familiar with is radios. So radio, the actual transmitter and receiver in the radio is a layer 1 function. The fact that when data is ready to be transmitted from one device to another, the transmitter is prepared and turned on. The data is sent across the radio link, starting with the data link layer that we're going to talk about later, and received at the other end, decoded and handed back to that OSI stack that exists in the receiver on the other end. Then the receiver on the other end might have to say, okay, I got it. And so exactly the same process occurs going back the other way. So radio is just simply another physical layer network. One device connected to another device. So typical layer 1 systems, they have a maximum transmit power level. Have to have enough power to be able to communicate what we need to say. Too much power, we're wasting it. Too little power, we're not getting there. And so we have to transmit the correct amount of power. We have to have a minimum receive sensitivity. Many things determine what their sensitivity is. Everything from bandwidth to how much amplification there is in between the two physical connected devices. The data rate is based on channel bandwidth and signal to noise ratio. There's always a minimum or a residual error rate at the maximum signal level. No two modems are perfect in talking to each other. And so in the physical layer, there's always some kind of anomaly that happens that determines what our minimum error rate that we have across a link is. So we take that into account. We have what's called a link budget, that the transmit power from one interface to the receive sensitivity of the other interface is called the link budget. I'm allowed so much loss in between because of the power that I'm transmitting and the sensitivity that I have. And then of course there's timing requirements oftentimes. In the data world, data is hardly ever completely asynchronous. There's always some kind of clock that goes on, and there's some kind of synchronization that occurs. And so the PHY looks after all of these different modes, the synchronous data, if there's truly asynchronous like when I click on my mouse. If I click my mouse, my finger is not timed to anything, and so I've started a transmission down the OSI model stack simply by doing that, by clicking my mouse. All L1 interfaces, they need power, and they need an environment that they're designed to operate in. As usual at Tech Talk with Dave, we welcome your feedback, your comments, your new topic suggestions. Simply send an email to marketing@mbsiwave.com, and we'll be happy to take a look at your suggestion, and who knows, it might be the topic for the next Tech Talk.